Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 27, 2025, just yesterday. It shows that joint 2D and 3D self-supervised learning yields stronger spatial representations, beating standalone state-of-the-art 2D and 3D self-supervised models by 14.2% and 4.8% in linear probing, and reaching 80.7% mean IOU on ScanNet. The paper is titled Concerto, Joint 2D-3D Self-Supervised Learning Emerges Spatial Representations. And as we'll see later, the implications for model training are quite significant. In short, the method couples 3D self-distillation with a 2D to 3D joint embedding, offers a video-lifted point cloud variant, and includes a linear translator that maps features into clip language space for open-world perception, while producing coherent zero-shot visualizations. Also, the authors shared the official Concerto implementation on GitHub. You'll find the Pointcept codebase with Concerto packages, example configs, training and inference scripts, dataset pre-processing tools, and ready Conda or Docker setups. There are quick start guides, pre-trained weights and demos, plus integrated backbones and benchmarks for 2D, 3D, self-supervised learning. On Hugging Face, Concerto provides downloadable model weights, no visible parameter sizes, plus a demo space, and simple pointers for running inference and integrating into projects. Alright, Figure 1 visualizes principal components of point features, which means the strongest variation directions, mapped to colors to compare methods. The comparison shows that the joint 2D-3D approach produces smoother regions with sharper boundaries, so geometry and semantics align better. Raw RGB provides context, while the standalone 2D and 3D self-supervised models miss either shape or texture. The consistent coloring across viewpoints signals a unified spatial representation. Figure 2 shows a simple cognitive analogy that motivates the method. The top row depicts multisensory learning with see and touch feeding a shared concept, which means the model should learn a modality-agnostic representation that works across inputs. The center bubble denotes the Apple concept that bundles geometry, texture, and semantics. The bottom row illustrates single sensory retrieval, where touch or imagine can recall the full concept. Table 1 shows that joint 2D-3D pretraining yields the strongest spatial features. The concatenated 2D plus 3D baseline improves over either modality alone, which indicates complementary information between images and point clouds. Concerto tops linear probing on ScanNet with about 77% mean IOU, so a simple linear head already recovers rich structure. On ScanNet 200, it also leads with about 37% mean IOU, reinforcing the same trend. So Table 1 highlighted the gains. Figure 3 explains why by laying out the two-branch training scheme. The left panel shows self-distillation on point clouds, which means a teacher-student setup refines 3D features using a constrained clustering loss. The right panel depicts joint embedding prediction, where point features predict image patch embeddings using camera geometry, so the two modalities align. Together, these objectives encourage a single spatial representation that can be recalled from either input. Alright, two takeaways stand out. Joint 2D and 3D self-supervised learning yields a single, modality-agnostic spatial representation, and that representation is both stronger and more data efficient, hitting about 77% linear probe and 81% fine-tuned mean IOU on ScanNet. The broader implication is unified pre-training that scales to video, adapts with lightweight adapters, and aligns with language for open-world perception. That is it for the AI Research Roundup. I am Alex. Thanks for listening.